Welcome to the LCGC podcast, preparing for those nasty samples, solid phase extraction with challenging matrices. This podcast is brought to you by Biotage, offering innovative and efficient separation technologies for analytical laboratories. To find out more, please go to www.biotage.com. And now, here's your host for this podcast, the contributing editor for LCGC, Kim Decker.
Hello, everyone. This is Kim Decker, contributing editor with LCGC, and I'm here with Andrew Taylor. He's applications chemist at Biotage. Thanks for being with us today, Andrew.
Thanks for having me.
Well, why don't we get started then? First, why don't you share some examples of what would be a challenging sample matrix?
Sure. So some of the more challenging sample matrices that I encounter usually are around the EPA 608, 625, and 1664 wastewater series methods. These samples can include high total suspended solid influence from a wastewater treatment plant. They could be particulate-laden industrial wastewater samples and even restaurant grease trap samples. In one instance, we actually analyzed a biological sample. It was an olive brine, and we were looking for oil and grease content in olive brine, and it was particularly challenging because not only did it have particulates in it, but it also had high salt content, and it had a lot of biological matter.
Why do these samples have to be filtered before they can be extracted?
There's a few different reasons that you need to filter the samples before SPE can take place. The first reason is to ensure that the entire sample is able to be processed through the disk. Many of the EPA methods require that a full 1 liter sample be extracted, so it's important that you're able to process through this full 1 liter. If you're dealing with samples that have high total suspended solid content, it's important that pre-filters be used to ensure that this whole sample can be processed through. The second major reason is along the same lines, and it's regarding the capacity of the disk. SPE disks that are used for 608, 625 are 47 millimeters in diameter, and this allows for faster flow rates, but without proper pre-filtration, the active sites of these solid phase media can actually become physically blocked by particulates, and this can adversely affect the ability of the disk to capture the analytes.
Well, so when we're preparing a disk for extraction, what are some of the things we should consider?
When you're preparing a disk for solid phase extraction, you really need to examine the sample matrix first. The first thing you want to look for is clarity. If you have a transparent sample, this makes life a lot easier. You can visibly see what particulates are in the sample, if there's any at all. And in that case, you may not even need pre-filtration. But in contrast to that, if you have a completely opaque sample, then you're going to need a fair amount of pre-filters built in so that you can ensure that the sample can process through.
And can you process a sample that contains just an obvious particle like a pebble or a leaf or even a stick?
Absolutely. So those types of particulates are actually easier to capture than some of the more fine particulates. In that case, you can just place a fine mesh screen on top of your pre-filter stack, and that'll capture the larger sticks, leaves, pebbles. These types of things are more commonly observed in groundwater samples, but the principle still is the same.
Can you use glass wool as a pre-filter?
Yeah, glass wool is actually an incredibly useful pre-filter when you're dealing with particulate-laden samples. When you're assembling a disc holder for those really dirty samples, you want to start with a 1 micron pre-filter and then stack a 5 micron pre-filter on top. And then glass wool can be placed on top of the pre-filters themselves. When you use the glass wool, it's good practice to pull apart the glass wool in order to ensure that the fibers are going in all different directions, and this allows for the filtration to be more effective. A fine mesh screen can be placed on top of the glass wool to compress it down to make sure that you get consistent flow through the whole thing and you catch the large particulates with that as well. And if it's absolutely necessary, a filterage such as diatomaceous earth can be even placed on top of this. And this layering technique really allows for the analysis of those really tough samples.
What do you do if your disk clogs partway through an extraction?
This is a really interesting scenario. If proper pre-filtration is not used and the disk clogs or it becomes too dirty to flow through the disk, there are a few different things that you can do. The first scenario is only applicable if you have multiples of a sample. You can completely abandon that sample and you can reduce the sample volume and try the extraction again. If you do this, it's vital to multiply the final calculated concentration by your dilution factor. In most cases, though, this isn't applicable because you only have that one sample that the customer gives you. And this creates a challenging problem. The first thing that I would do is I would stop the flow through the disc of that clogged filter, and then I could set up another disc holder on another station and pack it with the proper amount of pre-filter material, and I could extract the remaining sample on another station. Now, when you do this, you need to combine both the extracts that you get at the end to make sure that all the extracted material is accounted for.
How do you know how many pre-filters you should use?
That's a great question. This is actually something that can only be determined by trial and error. I always like to err on the side of caution the first few times I'm writing a dirty sample. It's better to have too many pre-filters than not enough, and you can always back off on the amount later on. Once the extraction is complete, I like to lay out all of the components that were used in the filtration process. I put out a paper towel in the hood. I take the pre-filters out layer by layer. And this allows you to visibly see which pre-filters are dirty and which ones are clean, which tells you exactly which ones were useful in the filtration process. This gives you a better idea of how you should configure the Prefilter Stack next time a sample like this needs to be analyzed.
Should you use a 47 millimeter disc or a 90 millimeter SPE disc for extracting the really challenging samples?
When doing EPA method 1664, you always want to use the 90 millimeter disc if you're analyzing dirty samples. The larger surface area of this disc provides higher flow rates, and it's also more difficult to clog. The same idea applies for 625 and 608. However, this disc itself is not actually 90 millimeters. The disc itself is 47 millimeters in diameter, but there's an option for what we like to call the fast flow sediment disc holder. This disc holder puts a 47 millimeter disc in the bottom of what's a barrel of 90 millimeters on top, and this allows for high surface area 90 millimeter pre-filters to be stacked on top of the 47 millimeter disc, and it leaves plenty of room for things like glass wool filter aid. And this disc holder is really the key to being able to process through those dirty samples.
Well, so how do you complete your extraction if you form an emulsion?
In SPE, it's really rare that you should run into an emulsion, but in the few instances that you do, the best thing that you could do is use a phase separation membrane and try and physically separate out the emulsion.
What should you do if your sample's oily or soapy?
So if your sample has a visible layer of oil, or if it has some surfactant-looking things in it, the best thing that you can do is stack a bunch of pre-filters and put in a layer of diatomaceous earth. That diatomaceous earth will most likely catch whatever oil and whatever soap that you're looking for, and you will be able to process through the rest of it.
That was a really informative overview, Andrew, and we appreciate your being with us here today. This has been Kim Decker, contributing editor for LCGC, and thanks to all of you for listening.
You've been listening to the LCGC podcast, Preparing for Those Nasty Samples, Solid Phase Extraction with Challenging Matrices. This podcast was brought to you by Biotage, offering innovative and efficient separation technologies for analytical laboratories. To find out more, please go to www.biotage.com.